Hello everyone. We're the radar-based patient discrimination group. I'm Shang Meng, and this is Park. So a little bit of overview for our project. So around like the world, like lots of people take medication, whether it's at home or in the hospital. But a lot of people like unknowingly take medication improperly in a way that can harm them or decrease the efficiency of the medication. So our job here is to kind of help with that, and we're basically identifying patients by their behavior when interacting with the pill bottle. So we're focusing on just pill bottles for now, but there are definitely other works that are going to be working on doing the same thing for other sorts of medication. And what we're working with is a 243C FMCW and Doppler radar sensor, which basically detects speed, range, direction, and motion. And we just use this to be able to get our information to accomplish this.
This is basically the system overview. So basically, we collected the data by telling 3 users to open the bottle, take the pill, and close the lid. So then this was sensed by the radar sensor. In the next slide, you can see the setup, how we collected the data. Then this sensor was then connected to the computer, which then gave us an output in .txt format. Then we processed the data and converted the time series data into a CSV format so that it can be used for machine learning models. And then we processed the data by like the the data was basically like irregular. So we tried to resample the data by 0.1 seconds so that at every 0.1 seconds the data would be there. And so a few users opened the bottle in quicker than others. So for that we used padding and added zeros to the data to make all of the data equal. And then we use feature extraction using DSFEL to basically extract the features from the time series data. And then we use the classifier to basically predict the user.
So as said before, our core of that acquisition was just having, it was actually just the two of us. Basically first we just did 20 samples each of us just opening the pill bottle, taking like the pills, aka, or we actually didn't have actual pills, but we had M&Ms. And then we closed the pill bottle and we repeated this process 20 times. So we both did this, and then to make for a third user, we actually just had Parth just make some more distinct actions that were, or just make some more irregular actions that he would normally do, like reaching into the pill bottle, take them instead of shaking the pill bottle and putting them on your hand.
Okay, so for the classifier, we used a classifier, bagging classifier, which is an ensemble classifier that fits the base classifier and and it takes the random subsets of the original data and aggregates the individual prediction. So for the training and the testing part, we used TSFEL feature extraction to uh, cut down the number of samples, and we used 80 to 20% testing and training data ratio.
So our results, we achieved an overall 70% accuracy, which is quite frankly terrible. But that is actually due to the small amount of data that we had. We didn't really have time to, because we were planning to increase the amount of data by either like taking more samples of each of us instead of just having 20, or using data augmentation, or we could do both. But we didn't really have the time for that. So results may seem like really skewed because one is an uneven distribution of the amount of the testing data. So we didn't have like four like samples for testing for 3 and 4 samples for testing for 2, etc. So that's why for we had like 100. We said that we have 100% accuracy for predicting user 3. So that's why it might seem that it's a little too good. And also it could be because that, as we said before, user three's actions are really distinct. So it just might have been really easy to predict user three because of while like we just have like subtle differences between our two because everybody like opens the pill bottle the same way, but user three we just did it a lot more differently.
So for the future work, we could actually like gather more data from the users, and we could actually use a combination of machine learning algorithms, and we could also implement feature selection model. So currently we just have the feature extraction part. So if we even implement the feature selection part, it would predict the user better. And also like we could use the data augmentation like jittering, scaling, and magnitude graphing to further increase the amount of data that we have.
Yeah, we'll be taking
Any questions?
So like the sensor, why is the sensor is inside the bottle?
No. I'll show you. So here is the sensor and here is the pill bottle. So basically, this senses the range and the speed that the movements are made here. So each and everyone have unique hand movements for opening a pill bottle. So that's why this is the setup. We could even try a different setup for better performance, but we tried to stick with this.
So you cannot move the pill bottle. The pill bottle has to be.
No, so yeah, it had to be basically in the range of sensor. The sensor had a good amount of range, so yeah, you can basically move around in this area. Thank you.